Hello everyone, good afternoon. Thank you for joining us today. My name is Sharon, I lead product management at PointFive. With me here today is Dor, who leads our research team. Say hi, Dor.
Hi.
So it's a privilege for us to be standing here today to tell you how we at PointFive actually found that cyber threat detection methods are actually an excellent way to detect cost inefficiencies in the cloud, and by that help customers around the world save a lot of money on their cloud bill. So the use of the word detection is obviously borrowed from the world of cybersecurity. And as you can see here, both Dor and myself, so do our founders, have a lot of extensive cybersecurity experience. This is why it was very natural for us to look for ways for how we can take the same lessons, the same concepts, and the same methodologies and apply them to the world of cost optimization. Let's get started. So we'll first start by reviewing the challenges that FinOps teams are facing today when it comes to optimizing their cloud. We'll then try to make the case that these are very, very similar to what cybersecurity practitioners experienced up until only a few years ago. Then Dor will take us into the detail of the technology and how we actually implemented those learnings in the world of cost optimization. And we'll close off by taking us from detecting cost inefficiencies to actually remediating them. Because at the end of the day, if you can't act on what you found, you did little good to save money. Let's see how this is being done. So as we all know, the cloud, so does reInvent conferences, obviously, is ever expanding. And when it does so, so are its challenges. The cloud is expected to surpass $675 billion this year alone, which represents a staggering 24% year-over-year growth. Now, while most of us are familiar with only a handful of cloud providers, there are actually over 100 different providers out there offering thousands of different services. Now, one might expect that as the cloud gets bigger and better, it will also be somewhat better at being cost efficient. And sadly, this isn't the case. And studies show that over 30% of cloud spent today is actually going to waste. Now, with all that, it's no surprise that 82% of organizations have continuously reported that cost optimization continues to be a top challenge for them. So let's talk a bit more about what these challenges are. So first, there's a clear access gap. This means that while engineers are the ones who are building products in the cloud, in order to do proper cost optimization, you have to have very deep intimacy with the architectures, with the building of the products, and this is something that is sometimes lacking. Second, while FinOps teams are considered to be the ones accountable for keeping cloud costs under control, they are not the ones usually with the ability to control. They don't have access to the code, and they cannot make changes on their own. This is why they will always need the engineering side of the house in order to act on their behalf. And last, the data is big, it's complex, and in order to do cost optimization, you have to deal with a lot of data that's very different, like cost, usage, metrics, or any other piece of data that can shed light on the problem at hand. Therefore, in order to do proper cost optimization, you have to bring these three components together. FinOps teams, who are the ones managing and orchestrating this entire endeavor, engineering teams to take actions, and the technology to facilitate this whole thing in an efficient way. So if this sounds pretty familiar to you, this is not by chance. That's because a very similar thing happened to cybersecurity just a few years ago. Security practitioners too were the ones considered accountable for their organization's security. That was despite having very little effect on changing stuff on their own, or even realizing and keeping up with the changes that engineers are doing in their code. That led to a shift-left motion, where basically many of the tools, practices, and the knowledge shifted higher upstream and back into the developer's hands. So instead of the old process where a security guy would run a vulnerability test just before a code is released to production, and then having to call the engineers back and asking for that vulnerability to be fixed, instead, the engineer now was equipped with the tools, with the knowledge, and with the right processes in place that are sometimes called DevSecOps in order to make sure that that vulnerability wouldn't be introduced into the code in the first place. So other than that, that technology or the introduction of these tools, more than anything, actually brought together FinOps together with engineering with the use of that technology in order to eventually provide better security for the organization. So I hope I was able to establish the connection between FinOps and security. And now Dor will take us into the detail of the actual technology that we implemented in order to use those lessons in the world of cost optimization. Take it away, Dor.
Yeah. Thanks, Sharon, for setting the stage right, the business context of it and the industry context. I'd like to go more into the technological point of view of that. So, talking about the solution right away, I first want to present the challenge and how that relates to the challenges that security teams faced in that same region. So the pursuit of a secure cloud environment is very much similar to the pursuit of an efficient cloud environment. Both fronts down here are common to each other. The cloud environment of the customer is ever changing with introducing of new applications, features, deprecation of those, and organizational changes. Second is the cloud provider itself. AWS here at reInvent every year reinvents itself, but actually has a more frequent type of changes around the year. And the last one is the adversary, where in the security realm is pretty obvious. These are the threats or APT groups, hackers, and stuff. And on the FinOps side, the adversary are engineering waste patterns. And in order to eliminate engineering waste patterns, we introduce DeepWaste. DeepWaste is a continuous detection engine that tackles cloud optimization or cloud cost efficiencies and surfaces up the cloud posture on an updated manner. It is based on a most extensive set of detection logics that rely on robust and really cutting-edge data ingestion system. It is being constantly updated and innovated by our 5X research team with the help of AI. It is already field tested and encompasses the learnings from billions of dollars worth of annual enterprise spending. And you can think of it a bit like an FinOps detection and response system. Completely agentless and completely seamless. And once we establish that this is kind of an FDR, a FinOps detection and response system, we want to compare it to a CDR, a cloud detection and response. Both of them share many of the means and problems or challenges, but have a slightly different purpose. A CDR system is aimed at reducing the risk of the organization, and an FDR system is aimed at reducing the cost of the organization. And failing to do so, or having false negatives, means more risk or more cost. All the other mechanisms are pretty much the same. So just to keep us in the context, I'm going to talk a bit more about the detection side of it, and we later on pass it back to Sharon to talk about the remediation workflows that follow our detections. So when we develop the set of detections that go through and analyze a cloud environment, we have three main principles in mind: continuity, actionability, and accuracy. Continuity is achieved by running the process daily and getting an updated version of your cloud posture or cost posture. Second is actionability. We are really biased into action. We don't give any opportunity, or we don't qualify a detection to be an actual opportunity if there's no clear action to solve it. And in that manner, an anomaly by itself is not an opportunity unless we know the cost driver of it and we know it is inefficient and there's something to do about it. Another example of how deep and how far we go to make it actionable we have a detection that detects S3 buckets that can benefit from moving to intelligent tiering storage class. Moving or transitioning the files there has an extensive, sometimes very large, one-time cost of moving all the objects. It also introduces a new monitoring fee, a monthly fee, and we take all those numbers into consideration to present two clear numbers for the engineer to decide and take action. One is the one-time cost of transition, and second is how many months or weeks or days will it take for that one-time investment to be ROI positive. And last is the accuracy, and of course we know that our detections are always only as good as the data itself, so we have a robust and extensive way of ingesting also external sources and internal sources by AWS. So once you integrate PointFive, how do we operate? How does it come into life? First, an ELT pipeline that ingests all the information. It can handle a lot of scale and many kinds of integrations, and we use dbt to model everything we know about the cloud into clear models. These models are enhanced by LLM, and if any Bedrock engineers are around, you made it very easy. We use it mainly for classification and clustering. For example, we classify EKS clusters based on their purpose, if they are for production environment or development or QA. And then we can tailor our detection based on that, because moving to spot on a development environment is much easier than moving to spot on a production environment. Our set of detections is ever growing and is run against all the data points that are prepared before. And what we really learned from cybersecurity is that it's not enough to surface the problems. You need to put the whole context in place to make it convenient to actually do something about it. So we present on the same place, and we will see it after, all the metadata, history, discounts, usage metrics, context graph, and any ad hoc calculations. We divide the categories to 5 different types. Unused, pretty clear. Underutilized are resources that are pre-provisioned but are not used to the fullest. And overused are resources that are not pre-provisioned, that are pay as you go and are used too much. Expensive type is a kind of a comparative category where we check 2 different regions or 2 different types, 2 different products that offer the same workload and performance but have different prices, and we express the lowest price of them all, and payment around commitments and discounts. So I want to show an example detection and how all those principles come into play. What you see here is a screenshot of a specific occurrence of an opportunity. This opportunity is an archival S3 bucket storing objects in non-archival classes. So here we detect an opportunity worth $5,700 a month, which is a large portion of the bucket cost. And we explain what we identified here. We identified that according to the last 30 days, the usage pattern of the bucket suggests that it may cost less on Glacier Instant Retrieval class instead of standard storage. And for that, we bring all the proof that we can to make the engineer really trust the process and trust the insight. The bucket size, we see the real problem here, or the real opportunity. There are no get or delete operations on that bucket. We estimate the new data retrieval and get object costs, which have new rates in Glacier Instant Retrieval. We put it all in one place to understand also some relational configuration. We put it all on one place with the new rates to tell you that if you're going to make that transition to Glacier Instant Retrieval, it will cost you $1,300 one time, and that expresses an ROI return after just 7 days. This is easy to make a decision like that. We also know that lifecycle configurations can affect the decision, so we bring all the configurations here, if there are any, to make you all stay on the same place and not start to look for and and lose the process. And on the top right, we have the action plan. You can send, assign, change status, or remediate some of the opportunities using our automation workflows. Lastly, we have a cost breakdown on the analysis tab that gives you an analysis or observability about the cost of the resource. As you can see, standard storage is the main driver of cost. And even a further breakdown to really allocate the cost drivers that exist on this bucket. So as you can see, no API request, no data transfer. That's why we understand that we can move this bucket to a colder storage tier. That was about the detection. I'll let Sharon continue on to explain how we take that into organizational processes to remediation.
Thank you, Dor. So remember what we said about the role we need engineers to take in the cost optimization process? So what we've learned is that in order to make engineers a significant part of the process, we have to meet them where they are. And one of the good examples for that is to fit into their existing workflows. So in this example, what we can see here is that a cost-saving opportunity, this is how we call our recommendations at PointFive, a cost-saving opportunity is creating a Jira task or any other ticketing task in whichever tool the organization is using, and that task is automatically assigned to the right person or team. By the way, automatically assigning that is something that a good tool can do, which goes a long way. From there on, the process moves on just as any other bug an engineer would handle. It would then first be validated to understand the problem. A change would be made to fix it. Then the loop would be closed, either back with the FinOps team to make sure the problem is really solved or any other kind of test. And then the ticket would be closed as done, either because it was resolved or in some cases it was dismissed because it was decided not to take care of that right now. In addition to fitting into existing engineering workflows, let's be frank, convenience is a very strong key to adoption. And this is specifically true when we're talking about engineers who are delicate creatures, let's say, speaking as one. So a few things that a tool can do to make things more convenient is one, to have things very easily to remediate. So what we call here a one-click remediation means that despite the fact that organizations may be reluctant to have a tool automatically make changes in their own environment, you can still go a long way in making things more convenient by offering or using AWS automation runbooks so that with a single click of a button, the change is implemented. Second, if the organization is used to running and building and maintaining their cloud code versus through infra as code platforms, this is also the way by which saving opportunities changes should be made so that you reduce manual effort and you reduce repetitive work. And last, we want our engineers to be 100% focused on building products. This is why we need to draw their attention into this world only when they're needed. This can be easily done through collaboration tools, pinging them through Slack, Teams, email, or any other form of getting their attention. So to close off, what we've learned in cybersecurity and implemented in the world of cloud cost optimization is that, like cybersecurity, cost optimization is a continuous journey and it's not a destination. It takes the right technology, which Dor told us about right now, collaboration, and most of all, empowerment of engineering in order to make cost efficiency a reality. Thank you all for being with us today. If you want to, please visit our booth 2166 if you want to get a full demo of our platform. Don't forget to fill out the survey, and we wish you all happy savings. Goodbye.
Thank you.